Hello, everybody, and thanks for joining me again today for another session of me trying to write Haskell and contributing to the drakon renderer project, which I try to do daily. So let's switch to the code view. So during the last session, I showed you one improvement I made to how we start the Docker file, how we start the container hosting the development environment, meaning GHC and Cabal and all the other executables hosted with Cabal. And also, we started troubleshooting the issue with the program not being able to correctly turn dcpaths into markdown. We detected two new issues, which are reported here. I think here. So, yes. So I had a little chance to think. Well, I had a chance to think about this a little overnight, and plan for today is to continue working on addressing the issues or multiple issues of balancing diagrams that have a loopback like so. I think we're getting close, and what we're doing so far is not really super hard, so it doesn't invalidate the foundational idea behind the new algorithm of balancing paths. So I intend to continue down this route, and let's see what happens. So today, let me just hide OBS. So I discovered yesterday that the zip function works fine if we just manually insert an empty list to this first slice. I would just like to see how it looks like before we do something with it. I'm not too worried about these warnings now. Yes, perfect. So we have two rows in this list of lists. The first row is empty, which is great. This is what we want. And the second row is just one icon. That's just icon 6. So I hope you have your nice coffee or tea or whatever you prefer. And let's write some Haskell. Today I'm drinking a pretty lovely oolong tea. All right. I think the problem I would like to focus on today is how to turn this manual insertion into something more programmatic. So I think balance first slice should return it for us. But let's see. I have a feeling that this already is only containing one row. So turning this into two rows could be tricky. Let's see what this returns. So this is good news, I think. So remaining paths for already has an empty list here. So all we have to do is to make sure that that empty list does not get destroyed as we take first. Don't want to jinx it, but maybe it's not as hard as I initially expected. So see, now remaining paths 4 look like slice 5, but only because I injected this manually. So it looks like take first needs to change a little bit to not remove that empty list. Let's see what takes first does. It's again not super complex. So for now, let's intentionally break it. To have them behave differently. So remaining paths has 2 rows and slice 5 only has 1. So I think it's also, again, down to how either take works or how the plus plus works. So let's run a quick test. Does clear work here? No. We have a list of simple numbers. Say take 1a. Perfect. So let's run an experiment. B is going to be an empty list. Let's say we want to take 1 from B. What do we get? An empty list. So what happens if we do a plus plus take 1b? Perfect. But let's not forget so this should work. But let's not forget the order is reversed. Oh, is it as easy as just this? Let's see. Okay, it was that simple. Now, it looks like we have mostly what we need. So instead of just printing these out, let's produce bpaths using the recursive function called balance. Okay, so this is looking interesting. Oh, yeah. Okay. Because the accumulator is empty. But let's see if everything else works. It still doesn't. Okay, that is fair. Let's see the step-by-step implementation. It's still not looking correct. Oh, because this take first is not working correct. Let's see if this works better now. So let's forget about these bpaths for a second. Let's troubleshoot these. So this isn't working. No. Excuse me for a second. Okay, it looks like well, I am back. It looks like OBS is rolling again. Let's get back to that problem. What is going on? I must be missing something really stupid. Hold on. Yes, I am missing something stupid. Result 5 does not return this first empty. So result 5 is a result of this. Balance first slice. Okay, so we can narrow down the search to only result 5. We know slice 5 is working fine. This is wrong. Okay. Let's do this. We know if this is right, remaining paths 4, result 5 is wrong. So in between here, something goes wrong. So slice map, remaining paths 4. So it's not null. We have icon 6 and icon 6 here. What does slice map do again? It folds the input. Oh, sorry. That's how a map works. It's key value pair. So it is correct. The key is the icon and the value is the icon. Okay, that was a little bit confusing. Okay, so the map only has two elements. It only has one element, which is fine. So slice map seems to be fine. What happens next? Balance first slice. That's not null. So we fold. Key rest. But we fold over the input. So if row is empty, we actually want to preserve it. Do we do something with that row? If the row is empty, we do want to preserve it. Okay, let's see how this works. So slice map, you're off the hook. But it's still not working. Maybe you're not off the hook just yet. Just a quick test. This is just a test. Hmm? Am I not giving it a list? Mm-hmm. So something like this. All right. Now it seems to be fine. We can let the slice map off the hook, and looks like we have our expected result. So now let's print the bpaths. Let's not print these guys. Okay. At the first glance, it doesn't look incorrect. It doesn't scream wrong. Let's see here. Here we expect 1, 2, 3, 4, 6, I believe. Yeah, 4. Oh no, the 4 is already end, so that's good. And here we expect 1, 2, 3, 5, 6. So we've done all that just not to see any changes. 5 and 6 is next. 6. Okay. This is looking good. But keep in mind we produce these bpaths manually. Let's do this. And we should get the same result. I'm already thinking about the PR. dcpaths to bpaths. Okay, the branch is good. Now, let's make sure we're copying the right thing. Ugh. You know what? Nope. Just to be on the safe side. Again, we expect 1, 2, 3, 4, and then 1, 2, 3, 5, 6. Perfect, that's row 1 done. 2, 3, 5, 6. Looking good. Issue resolved. So we're one step closer today to resolving our first primitive path with our primitive diagram with a loopback. So this is resolved now. And probably for another session, we'll leave the markdown to be fixed. And honestly, I don't have a good idea how to do this yet, because row indexed with number 4, 0, 1, 2, 3, 4 will only have one element. So the renderer will not know whether it should go to path 1 or path 2. So I need to figure something out. But in the meantime, we can delete this. We know it's working. Maybe let's leave this troubleshooting code. It will be needed for later. Let's clear all these slices that we use for troubleshooting. This is definitely progress. Qualified data list, let's see. This is in here. So all the complaints we're getting here are about the use of the head function, which I'm kind of better from period, but define I will look into this at some later stage, but for now I'm pretty happy with this. So let's do this. Let's add this. Bpaths from dcpaths working. And let's just create a PR. This is 130. And we will wrap it up here for today. This partially resolves 130, which we still need to fix markdown. Good progress. This does contribute to the milestone. Looks much better now, but we're still missing that last row. Right, so as we have the CodeRabbit AI reviewing the code, I think we should wrap it up for now. Again, good progress today. Next session, I'll probably be focusing on just resolving that markdown problem. And that will probably be our first loopback drakon diagram done, fully balanced, top to bottom. Very happy with that. So thanks very much for sticking with me. and for following the series. And I'll see you next time. Have a great day.